Hello, everyone. Welcome. I see we have a few people waiting. Okay, before we begin, I'd like to share my disclaimer. I am not a doctor. I'm not a spiritual master. I'm not an expert of any kind. I'm just a country pumpkin sharing his theoretical perspective for entertainment purpose only. Today, we will be sharing how to nano with caustic and fire. Let's begin. Let's backtrack a little bit. We have, for creating nanomaterial for GaNs making, we have either by fire, by caustic, or other means, like through plasma, if people are able to create that environment by, depends on our creativity. We can do by electricity, but that's require a little bit of experience. We're gonna go over two common methods: fire, which is by either by the gas stove, wood fire, just campfire, or by match or lighter. We're actually lighter than a match. And blowtorch, like this here. And caustic. With caustic, there's hot and cold. And I will go briefly over both of those. So welcome, Kim and Ha, to the session. Lucky for you, or maybe not so lucky for you, you get to hear me twice. So let's go with, well, let's go with the easy part first, the caustic, because it's not really fun to play this in a bedroom with a fan blowing in my face. Okay, with caustic, we have hot and cold. It's not really cold, we call it room temperature. Why do we nano copper instead of other materials? Copper is the easiest one to nano coat because other materials we can nano coat, but it doesn't come out black like copper. When it is not black, it means it's not absorbing all the energy coming from the environment. It radiates partially, some, or a lot, depends on the material. Oh, we have some friends from Mexico. Hello, Tanya. Hola. So we will, for our purpose tonight, I will share how to nano coat copper and zinc. Zinc is very important in the GaNs making process, and for new people, I guess they have not learned how to nano coat other material other than copper. Zinc is a little bit sensitive to nano coat by either fire or caustic. If you nano zinc by caustic, you have to do very lightly, else because zinc and caustic will create a chemical reaction. If you put zinc in a caustic solution, it will completely dissolve the zinc very quick. Or when you try to do cold caustic or warm caustic or temperature room caustic in a container and you spray like you do with copper, then chances are if your zinc is too thin, like the one I have right here, this is 99.9% zinc, very thin. When you try to nano coat this, it will fall apart very quickly. So when you mix it in a container like this, use, I don't know, 1/10. There is no exact ratio for diluting the solution to nano coat zinc. Just dilute it, let's say 1:10. If you're going to use 1 teaspoon for regular copper, use 1/10 of a teaspoon and see how it works out. And you can spray lavishly with 1/10. But if you use the full strength solution and you're trying to spray on this like you spray on copper, kiss it goodbye. The same thing with heat. When you apply too much heat on zinc, it disappears, it evaporates. So now I will show you my, let's start with the zinc, the what you call the NaOH, the caustic solution. Mr. Keshe recommends when we do caustic about 80% NaOH with the sodium hydroxide and 20% sodium or potassium hydroxide. Why do we use 80 and 20? Because we have the mixing up of the caustic. It creates a better flow, a gradient. So the nano-coating, we have different strength within the different layers, and it's create better flow of energy within the nano layers. That's why we mix approximately 80% NaOH, which is caustic soda. Some people call lye. Lye is the commercial version in the store, which is the impurity is not that high, the quality is not that high. So when we're getting sodium hydroxide, try to aim for at least 99% because it's easily to get on the market. There are 80% and lower quality sodium hydroxide in any chemical store. For potassium hydroxide, at least 90%. In other countries, in Western countries, you can get 95 and above easily. But for a country like in Vietnam, mostly of them 90% they import from China. If we get the one from Korea with 95%, the potassium hydroxide from Korea is very expensive in Vietnam because of the import in. It just costs a lot more than just regular, normal potassium hydroxide. So that is a disadvantage of some of the. It depends on where we live. So yes, 80% NaOH and 20% KOH. If you have to buy lye for NaOH, but lye is like a drain cleaner. It has a lot of impurities in it. It's easily get at Home Depot or other places. It's better to buy online and from a chemical place or online store, eBay, Amazon, and get 99% quality for soap making because sodium hydroxide is used for soap making. You have oil plus soap, then you have oil plus sodium hydroxide, you have soap. Soap is made from sodium hydroxide or potassium hydroxide. Potassium hydroxide is used for liquid soap. Sodium hydroxide is used for bar soaps. So look for soap making, sodium hydroxide for soap making. It has better quality for our health. Let's put it that way. It's very common. Lye is the last resort. Because when we put things in caustic solution, when we throw things into gas state, we want as much impurity as at least as very little, at least impurity as possible, because when you put them into the plasma state, if you have a lot of heavy metal like lead and cadmium and all that stuff, it's not very good for our health, because we can accidentally turn all those heavy metal into plasma state, then we radiate those energy out because we're using impure material like potassium hydroxide and sodium hydroxide. So in this container, we can use 1 teaspoon at least. You can use more. There is no exact science or ratio. Okay, you have to use this amount for that amount. This container is about 1 liter. With 1 liter, you can use 1 tablespoon, 1 teaspoon. I used before 1 teaspoon, it works fine. 1 tablespoon, it still works fine. So use your discretion and try it out with at least the minimum amount. You can put 1 tablespoon in here, no problem. When you use caustic, when we are making gas, I normally recommend distilled filter water, not the home water, as the minimum. Rainwater, depends on where you live. Rainwater can be soft or hard or acid rain, so we can't really use rainwater as saying high quality because of the condition we're living right now with acid rain. If people have heard of it, chemtrail, other chemicals, even before chemtrail, we have all industrial waste going up into the cloud and it comes down in the form of acid. So acid rain destroys forestation and all that stuff. And so it depends on where you live. The rain could be good quality or not so good quality. The rain where I'm living right now is hard water instead of soft. Normally rain is soft, meaning it has very little minerals in it. It's very good for pesticide to use. When you mix soft water with soap to make what you call a solution to spray on pests as a wetting agent, you need soft water. But that is a different topic. And here we need good quality water so that we don't add impurities to the solution, accidentally turn them into GANs, the extra energy that we don't need. So in America and in Western Europe and First Nation, it's easy to get distilled water. In America, you go to Walmart, you get 1 gallon of distilled water for $1. It's very inexpensive. But in Vietnam, like where I'm living right now, getting distilled water is a pain in the ass and expensive sometimes. So for using the solution, I recommend distilled water because, or at least RO water, reverse osmosis water, with no minerals added. So you get the least amount of impurities and extra stuff in it. Because when you have sodium hydroxide or potassium hydroxide, and you add any solution, any water with minerals inside, it will turn them into C GANs or a composite GANs. For example, if your solution has a lot of magnesium or copper or let's say calcium or potassium, when you put sodium hydroxide or potassium hydroxide in it, it will turn them into GANs, like C GANs. Because when you put salt water solution, add it to sodium hydroxide or caustic, then you get it into C GANs. You have a composite of all those minerals. It's like when you put the caustic in a solution, it adds hydrogen it releases hydrogen into the water, a source of energy. Those energy charge up all these molecules and atoms of minerals in the water, and it pop like popcorn. Now turn into a little tiny GANs, a little tiny sun radiating energy out everywhere. That's why we have to be very careful using caustic with things, because we can accidentally turn them into GANs. And some people, when they were using caustic on the copper to make the nanomaterial, and they don't wash the caustic off the copper and put it directly into the reactor, and that caustic can possibly react with the salt solution, turning them into GANs. And people think that CO2, oh, I'm getting instant CO2, but what they're getting is instant C GANs, because the minerals in the solution interact with the caustic. Because when you make salt solution, there are two options. You can either use sodium chloride, which is 100% sodium, or you use the other one, the salt, where it has all the minerals content still in its natural form from the sea, all the minerals. That is two kinds of salt you can use for making the GAN solution. So most people think when they're using pure white salt, it is just sodium chloride. It lacks all the minerals we need. That is the worst thing you can eat for food when you use salt. When you eat food with salt, eat the natural sea salt with all the iodine, all the minerals in it. Don't get the white, the pure white stuff that's just plain old sodium. Just make it salty, but lack all the minerals. When you're mineral deficiency, you're prone to sickness. Linus Pauling said, 100% of the sickness is from lack of minerals. So because of the diet we have today, with the poor soil in the land, we're depleting it, without replenishing it, and we're eating lower quality food, we easily get sick. That's why we're making all this GAN technology, GANs material, and preparing all the nanomaterials so we can provide it with the life force energy that we need, that we are lacking from our everyday food. It helps to balance our mind, our emotion, and our body, and everything else. So let's get back to the subject of lye solution. That is how important it is to use distilled water in your sodium or potassium hydroxide. And once you have that, make sure you use HPDE plastic, high quality plastic. Sodium or the caustic will eat away cheap ass plastic. Do not do that. Your caustic will leak and it just create a mess. Because caustic is very acidic, or not acidic, highly alkaline or highly acidic stuff will eat away our skin. It makes our skin very itchy. It's bad reaction. So do not breathe in caustic. Do not spray it on yourself when you use this. Make sure you wear your safety gears, your goggles, your mask, and your gloves. so that you're not being impacted by it. When you handle nanomaterial, make sure you use your glove. I'm not using right now because I'm filming and it's very inconvenient, but this is for educational purpose. For practical application, have your safety gear, your eyeglasses, your N95 mask on, and your gloves to help protect the skin from the caustic. Now that we have the caustic out of the way, I would not show hot caustic. Hot caustic is when we use hot water mixed with the caustic. That is, you can follow that on KF Vietnamese. There is a video tutorial by Armin. He did a very good job, very detailed explanation, and you can use that. It's in English, voiceover in Vietnamese for those that are Vietnamese. But today I am going to share the other method, which is because when you use hot caustic, the steam go up. It's very harmful for our health, especially when you're in a closed environment. The cold caustic, a warm caustic, a room temperature caustic is easier and safer and quicker. What we do is we can use, we add the caustic first into a glass container. It's always optimum to use caustic in a glass container. Then we put in the still water, mix it well, then put it in here, and we can spray. Like I have right here. What I have right here is a container that you're not supposed to use. That is a cheap container that you can easily find. Well, not easy, but in the United States, you don't have this container. You don't have this problem. Western nation don't have this problem. You have third nation like Vietnamese or Vietnam has this problem when you have cheap plastic like this. It cracks very easily. So do not use this. I was using whatever available, but it's hard to find big container like this in HPDE. So I was using this temporarily. As you can see, the plastic, the caustic will cause the plastic to crack. Maybe I give it a month at most. It will crack the plastic here. Eats away at the plastic. So we use a container to seal the nanomaterial. You can use any container, any size, depends on your nanomaterial size. For this one, I'm using a coil from a graph. So when you put the coil in here, make sure airtight. You spray in here, let's say, there is no science. Do what you feel like it. I use about 3 spray. So in here, just spray like 3 times inside, 3 times, 4 times. You're not gonna get fined for doing more or less. Maybe it depends on how quick it is. You can do it twice a day, 3 times a day, 3 days in a row, or it just depends how quick it gets black. But you can do like first day, about 3 times a day, then do it for another 3 days and see how it works out to see, because we can leave in here for at least a month, because set it and forget it. It will get black within, let's say, 1 hour to 3 hours, you get completely black. Even though it's completely black within 1 to 3 hours, the nano layers is not enough. We need about 30,000 to 50,000 nano layers. The longer you put it in there, the better. Minimum of 1 week if you have to use something really quick. Emergency cases like you trap and I'm going to die with the next day, then within a few hours, fine, within a day. But when you have time, create enough so you leave it there for a month. And once you seal, when you spray it, put the lid back on, seal it tight, and leave it in the sun to marinate for a month. Then you get a very good, nice black layer. And one thing that you do need to prepare your copper before you do the caustic is you soak it in, like for example, like this copper right here, you soak it in the caustic solution, completely immersed in the caustic for at least 24 hours, because you will remove all the dust, all the grime, all the grease from your hand working in it. So when you take it out, make sure you wear gloves, so your grease on your hand, all that dirt don't get contaminated on the copper coil, and which create the reduce the quality. And also when you do your amino acids get connected, get oil is on this copper, then you have the direct connection to the GaNs you're making, because you had your amino acid all over this thing when you're using it without wearing gloves, and you put it in to make GaNs. Then you have a direct connection because of the oil on your hand come in contact with the nano copper. So make sure you soak it in caustic for at least 24 hours. Then you take out, and you can hang it on in here. If you soak it in caustic for 24 hours, you don't need to spray like I did earlier, because it already immersed in caustic. You only just have to hang it up and you're done. If you don't have caustic to soak in, you can soak in with a lemon or lime juice for, let's say, maybe an hour at most, of 5 minutes, 15 minutes, depends on the thickness of the copper and how dirty it is. If it's just slightly greasy, dirty, you can soak it in for 10 to 15 minutes, take it out, you can see it's nice and shiny and bright, dark brownish red. So it's decent, it's very good. And you're done. Then you can do it the caustic that I just recommend. And when you're done, after 1 month of leave it in the container and to dry this thing, you have to untighten this thing, then just leave a crack, a tiny crack, so it dries slowly. It has to dry slowly to make better nano coating, according to Mr. Keshe. Do not just open up like that and expect to dry and get it out right away. Let it dry slowly for the next 3 days at least. Every day, try to polarize it, meaning the draining will not be correct, because when you nano coat by caustic, the atom, it's called the atoms, the molecule, the energy goes in every single direction. So when we do with polarizing, with the voltmeter, we are creating a flow so that energy goes in one direction. So it becomes more efficient when we put it into use, into application. With the voltmeter, you can ask Mr. Google how to use, but you set it to the volt meeting right here, the volt setting. You can't really see well on this. There's a volt setting, and you set it on 20 millivolt will be fine. Set on number 20, like right here. You can't really see that well. It doesn't zoom in very well, but you can ask the Google show you how to do. But basically, you have you can touch one piece. The red piece is the positive on the material, the copper, and the negative on the body you're hanging on. You not use aluminum. You can use the bar to hang on. Copper, brass, iron, stainless steel. Iron will nano coat and will not very well. Use stainless steel or brass or copper rods to hang across the container. Then you can do it that way. You nano coat that way and do it twice a day. Just leave it there for 5, 10, 15 seconds just to create the flow so that things flow. Plasma flows differently than electricity. When you nano coat this, remember, see this container at the end? Always create a loop so that it loops back into itself, into the wire in both ends. The loop has to loop back, because when plasma runs through the wire, it will leak. So when you make that little hook, the energy flow back into the wire, so you have less leakage into the environment when you have plasma. Plasma can go both directions. When you have electricity, it usually goes one way. Plasma goes either way, up or down this way, depends on which is the source, where it is coming from. It can switch polarity instantly. It's not limited in one direction. It can switch polarity and direction whenever it wants. So that is the hook you make before you nano with the caustic. So that is how you do it. And just do it 3 times for 3 days, at least minimum of 1 time a day. Or you can do like what I do here. When you hang it on the container like I do, you create 2 rods to hang. You can make like a hook, a hanger to hang the copper on both ends. And at the end, you can put either the battery, and 1 battery here, and one battery over here to create a circuit. When you have that circuit moving, it's always creating that polarizing, create that flow of direction so that you have a better nano-coating layer. And at the end of 30 days, you don't have to do anything. This is set it and forget it. This is for lazy people like me. I don't like to polarize at the end or have to check on it for 3 days. I like the lazy way. I'm a lazy person. I like to do it this way. So with the battery, you connect. Let's say the battery here is a positive here, negative here. Then at the other end, you do the opposite. So positive and negative. So it's create a loop around constantly. What I have right here is the plasma battery, not the regular conventional battery. I use a plasma battery to create the flow. There are 2 plasma batteries on this, but this one right here fell off doing transportation to the new place. I have to create a new one. But basically, with my setup, I have 2 plasma batteries, one in the front, one in the back, to create that continuous flow, and you see a better nano-coating layer. And it's an easier method of set it and forget it. And when you do a large amount initially in the beginning, you have so many to use later on without having to waste your time making it, because you can use a much bigger container. This is just a sample container for a small amount. When I'm starting to make my nano-coating, I will use the 5-gallon bucket, the paint container, or when you in the United States, you can easily get food grade bucket, or you can use the bucket from Home Depot or Lowe's, the 5-gallon bucket for like maybe $5. You can use that bucket. If you have some other sources from restaurant or other places where you can get food grade bucket, that would be better. Get food grade bucket, but the minimum, get this clean bucket from Home Depot or Lowe's, and just drill a hole on top and put with Home Depots and Lowe's and hardware store. They do sell those brass bar. It's about very small. It's about 8 gauge 8. Gauge 8, which should be good enough and thick enough. It's about maybe, I don't know, 10 millimeter. It's thick enough to hold between it has to be thick and strong enough to hold a lot of McGrath coils when you put between the bucket. So when you drill a tiny hole enough to put the brass bar, 2 brass bars like this into the 5-gallon bucket, and you can hang your McGrath coils. You can hang your regular coil, but you have to set up hooks. So you can hook them up on both sides. If you have, like, for example, like this guy right here, where did I just put? You have to create a hanger for it, to hang it from like this, like a V, to hang it from this side to this side. You hang it on both sides, like 2 wires going up, and you just hang it like this. And you have one wire here, one wire here, and you hook it up on the top, so it's dangling like a swing. If you dangle like a swing, then it has a connection to both sides, and you can easily create a loop for energy to rotate with the plasma batteries or with the regular battery, and you don't have to worry about polarizing it at the end of the time period. Just let it dry slowly. You still have to let it dry slowly after the month. Open the lid, let it open a little bit, then it slowly dries for 3 days or longer. You can leave it for up to a week, and it has a very good nano coating. So once you have for a week or 3 days a minimum, then you can take it out, wash it in distilled water or RO water. Just wash it thoroughly so that the caustic on the outside, try to remove as much of the caustic from the inside the coil as much as possible. So when you put it into the solution to make GANs, it doesn't interact with the salt water to make C GANs. That's the warning caution I have, so that we complete the process of nano coating with the warm caustic or room temperature caustic. It's very easy, very simple to do, and it has a very nice black color that is hard to fall off, unlike fire. And when you use it with caustic and when you try to measure it with this voltmeter, it shows nothing because it's an insulator. So this voltmeter will barely read anything, if at all. Normally, it might give like 50 millivolt or less or none, depends how well your nano coating is. When you do this with fire, you get a higher reading from the voltage. And when you use fire versus caustic. When you make a plasma battery using caustic and you use this to measure, it shows up like 50 millivolts. When you use fire to make this coil and use it for the plasma batteries, it can come up to like 500, 600 millivolts. So half a volt easily. From 400 to 600, could be 300. You can see the voltage using this when you use the fire method. So when you're trying to use the plasma batteries for the when you're trying to make plasma batteries to create a flow, you might want to try both the plasma battery and the regular fire. I mean the caustic battery and the fire battery. In another video later on, I will show you how to make the plasma batteries. It's very quick and easy and simple to use. But in the meantime, you can use a regular AA battery like I have here to create the loop, the flow of energy constantly. So easy management. I think that I have all I have right now for nano-coating. With caustic, you can nano-coat any material. You can put anything in there. You can hang the zinc, but I said with the zinc, just make sure you dilute it really well and put it in a separate container because it cannot use the same concentration as the copper. So nano the zinc, do the same process, but put it in a different container. It's very sensitive to caustic. And this zinc, you have to nano-coat to make the cup of the soul. Cup of the soul is the king of all cups for because zinc balances the emotion. When you nano-coat the zinc, it has a stronger charge, more energy, more effective. You have a bigger range of that. So that is good to balance the emotion. Right now, people are making just the zinc and copper and the CO2 together, or the zinc and the copper. When you make those, yes, it get a good ratio, but when you need a bigger bang for you have much more stress, more emotional imbalance, then you want a higher purity of zinc, 100% zinc, then you have to use nano-coat zinc and regular zinc, or you have all three pieces of nano-coat zinc. So later on, I will share in a different video how to make cup 1, cup 2, cup 3, cup 4. Cup 1 and cup 2 is 1 cup, 1 life, version 1, version 2. Version 1 has all the copper, the zinc, the CO2. Version 2 is all copper. Version 3, you have the 1 and 2 connect. And version 4, cup of the soul, then you have the soul, the cup 1, cup 2 connect to cup 3. Let's see. Now we're done with the caustic. Let's go to the fire. Fire it's easy, fast, tricky. I'd say I just found 99.9 purity zinc at most on market. Yes, it's very easy. Copper, you nano-coat, you have a variety. Normally with copper you use, in America, normally you use this kind of wire right here. For making a graph, making paint pen, making other things that you can use. This is gauge 14, which is 1.6 millimeter. For those outside of the United States, it's 1.6 millimeter. It's gauge 14, the normal standard house wire in the United States and probably Europe as well. They use gauge 14. In Vietnam, they use cheaper wires, maybe other countries as well. So it's harder to find the higher grade wire. You have many wires to steal fire. This is those thick wires used for maybe car cable connection, wires inside the car, or in the housing where you have thicker. This wires normally don't use in Vietnam for thicker wire house connection because they're too cheap. Well, people are cheap, not the wire cheap. They're trying to get the minimum out of that thing. They don't use high quality wires like in the West where you have a minimum of 14 gauge and you have bigger wires, bigger things. You use up to gauge 8 and stuff. But that is not very common in Vietnam, where I see where people do housing construction, the wire is just below bare minimum. So this wire you can get when you're trying to make nano-coating copper, and you use with the material you have. If you cannot get the plates, like in the United States, copper plates and zinc plates are very easy to get. For example, in Vietnam, it could be harder to get the zinc plate, not easy accessible, or copper plates not easy accessible, but you can use your mind. You can cut the copper tube, you go to the store, you buy the copper tube, and you cut it in half, then it becomes, voila. You got a copper tube, you got a scissor that cuts steel, stainless steel, tin, the scissor that cuts tin, you cut the copper tube out, flatten it out, and you got this. Amazing what your mind can do when you're trying to be creative and to solve problems that you work with limited materials in a constricted situation. Then you use copper tubes, cut it out. Copper tubes is easy to get. When you make for home use 1, 2, 3, 4 times, go to the store, get the copper tubes, cut it, then you have copper plate, and you use copper plate. And if you need copper wire, you can't get it at the store. Oh, you got so much to choose. And this is the typical wire, household wire in Vietnam. This thing is like, I don't know, 1 millimeter or 75 to maybe 1 millimeter. It's very thin. Most of the time, when you go to the store, you buy, you don't ask for pure copper. They give you copper plated with aluminum inside. Most of the household wires in Vietnam, I see are copper plated, aluminum inside. So when after you use for a little bit, it get burnt, and it get burnt completely. It's very poor quality. Get pure copper for wire to use. It doesn't matter what size. It's optimum to get 1.6 above. For McGrath, you can get up to 2 millimeter. 1.6 is the minimum, which is gauge 14. You can get 1.8 is better. 2 millimeter, you're gonna get one hell of a time to work with that boy. 2 millimeter copper, you have to get your can of spinach and your milk out, because it's very hard to bend. It's very hard to bend those things. 1.8 you might be able to manage. For those ladies out there, 1.8 might be tough. You might break a few nails during the process. It's better to get the 1.6, which is gauge 14, to work with the copper. When copper is heated, it becomes soft, malleable, easy to bend. But once it's not heated yet, it is very hard to bend, especially 2 millimeter. For copper wire, for zinc wire, for nano-coating, zinc wire, well, zinc, the thicker the zinc you can get, the better for the plates. For the wire, a minimum of 2 millimeter. You're gonna get much higher, but don't get too big where you can't make it into a coil. I would say between 2 millimeter to maybe 10 millimeter. Just play with the numbers to see what is available on the market, because your option is very limited. So I put it this way, your option is really limited on the market, what size you can get for the copper wires. You can get probably from 2 to 4, 2, 3, 4, and maybe even 5. But I don't think you can get bigger. You have to have special order for that. But the one I saw online, you can have between 2, 3, 4, maybe 5, and get those, and you can work easily. Zinc is very soft, easy to bend, not like copper. So here I have a varieties of copper we can use from the house. So when if you don't have a copper for pipes, and you don't have the copper plate to work to make, for example, 1 cup, 1 life, you can use a mix of, see all these wires I bent out. Now you got a plate. Who needs a plate when you have is like so many tiny threads of copper? So you tie them all up. Now you have a bunch of wires you can hang just for flat in place of the plate. And you connect like normal. Because your wire is small, you can bunch it up like I do, connect like 3, 4, 5, 6 of them, and you have your makeup wire plate, scrub, and just be creative. There is no restriction of what you can or cannot do. You make the best use of what you have. You use your creativity to create all this stuff, but make the best use of whatever you have. The blueprint is just store for reference. It's not that written in stone, okay, you have to do it this way, or God will struck you down and you go to hell. Keshe plasma is different than conventional science. Conventional science, you have a formula A plus B equals C. The Keshe plasma science works the same way the universe works. The universe does not have a ruler, a scale, so a measuring cup. It works within the environment, whatever is available to create the product. So we make the best of what we have. So you use 3 of these because these wires are very thin. You can see right here. When you use fire, it burns very quick, very fast. So use very low heat. You can use from the stove or the lighter or the torch like I have right here. Go very gently and very fast because they are individual and they burn up very quickly. Do not let your copper go red hot. When your copper go red hot, that means it's gonna flake up very easily. Even if your copper is not red hot and just black, by doing fire caustic, it flakes up very easily. That is the disadvantage of using the fire caustic because the copper layers easily crush, easily get flake off when we are not careful, when we to heat, especially when we first do the nano coating with inexperience. After we are getting more experience, we use the proper control of heat, and we get it just perfect enough heat, not too much to burn, and doesn't flake that much, and we accept. So when you're done, just flake it up a little bit, shake it up a little bit, bang it up, bang it lightly against something. No, don't bang it, just shake it up. Okay, this is too small. When you bang it against something, you're gonna crush the nano layers. So just shake it up so all the dust, all the flakes fall off, so it doesn't fall into your solution when you dip it in, make it look nice and earthly, cloudy and stuff like that. So before you put it into your solution, put it under the wash it briefly with clean water, RO water, or distilled water, so you get all the debris, the dust off, all the impurities off before you put in your solution. Then your solution will be clean without having extra particles and flakes dropping down to the bottom, make it look a little bit yucky. If you want to have nice, perfect white zinc or CO2 gains, and you don't want to have the black particle down the bottom, you don't want to waste your time filtering it, then take some time in the beginning to wash your copper, nano copper with fire a little bit, so it's a little bit clean when you put it in. And depends on see this guy right here, because he's all wrapped up, you can use stronger heat and we will not overburn as quickly. These guys gets burned very fast because the wire is very thin. So the amount of heat, the speed at which we move the torch depends on the size of the copper, whether it's threaded like this, it's threaded like this, or it's solid copper like this. Solid copper like this takes longer to heat. So we have more leeway to work with. So we can go a little bit more slower than we do with this. Because I have the fan blowing in my face right now, it's not a good idea to use this torch. First, I'll do a test for you guys to see we nano coat this. I've never done it before. Let's try it this way. Vietnamese people are smokers. One advantage is we have this guy. We're gonna nano coat. We are going to nano coat with, because if you can do it with this guy, you can do it with the gas stove, the fire. So when you do it fire, do it one way, meaning you nano coat from one direction. Doesn't matter if you were left, right, left. Do it one direction to create better flow. So we, with this one, it's very hard probably to do with this guy, but with this guy and my wire, for example, is this thin. So I can probably do with this guy and it will be just very fine because it's harder for me to overheat. It's harder for me to burn the wire. I have better control over the heat. And let's see how we do. Here we go. I have the fan blowing on my face. Oops, let me bring this up. maybe I just have to talk my way through it. You're not gonna get a live demonstration of me burning this thing without me getting out and shut the fan. Here we go. Let's see if we can do it. Okay, that doesn't work. Okay, I guess so much for a live demonstration. I'm just going to explain it further because I guess you can imagine it. I can explain it. It's easy. It's not that difficult, and you just go try it yourself because this is not rocket science. With this wire so thin right here, it is just like 1 millimeter, so thin. We don't need that much heat. We can use a candle, gas stove, fire pit, any other source, and we just use like I use this here for demonstration purpose. I leave the wire on to show you the size, and it's just something I can hold that my hand does not get burnt. So we can use this clip right here. When you go to a stove, candle, a wire, use a cheap, any plier, anything to hold, and just run it through, like go in one direction. So, and it's better to use over the gas stove. Fire pit is harder to put there to go in one direction because the fire is pretty big. But from a gas stove, you can go one direction and just go upside down like this and go from over slowly until you're done. And the height up above the gas stove depends on the thickness of the wire. For this guy, it's very thin, so don't put it to the blue flame. Even this blowtorch right here, there is the blue flame that come out about right here. With thick copper, like the 14 gauge copper, you have to touch the blue tip of the flame and go slowly. If you don't touch the tip of the flame, it goes longer. But for this guy right here, do not touch the blue tip of the flame or near it because you get burnt very fast. If you're trying to do that, you go like this. You go very quick. When you use this torch on this small wire, go like this. And then go again. Just go down very quick because it's going to burn very fast. Then this way it prevents overburning, overheating, and flaking a lot. And initially people recommend do it heat up, let it cool, and do it like 3 times. But I'm too lazy. It's just too much work for me. I find it's okay to thoroughly do my copper the first round. When I go through, make sure it's nice and black initially the first time, and let it cool down, and I can use it with no problem. So I don't have to do like let it cool down and nano again 3 times. The first time I did that nano coating by fire, I did in the middle of winter. It was cold as hell outside, and trying to nano coat that 3 times, let it cool down. My hand was frozen before that thing even cooled down. So when you have the next time, it's this guy right here. This thing gonna burn instantly fast. So do it super speed, super fast, and just blow right across really quick. But this torch is not practical. You have to turn it down to the minimum, the lowest setting you can have. So even so the flame doesn't go out, and use it, and it works much better. The same thing for lower wire. This one it's more flexible. It's thicker. You have more leeway, but slowly doing it works fine. Even if you have the lighter I saw earlier, with the lighter like this, you can use to heat up this wire, especially in a case where in Vietnam right now we have lockdown and we have limited resources of what we can do and get, but Vietnamese people are smokers. So that is the perk for being a chimney, is you have a lot of these and use these guys to nano-coat this guy perfectly, because it creates, I think for me, it should be a decent amount of heat to nano-coat this thin wires, or the thin wires were here when you just roll it up into one thread instead of all the other threads. When you roll it up, twist it up and roll it up into one, then you just go slowly over, then you can nano-coat. That is called being creative. That is called using your mind to take advantage of what you have in the environment. And that's see, monkey do. That's the main theory behind Keshe plasma science and technology, is that to enlighten people, to use your mind, imagination, exploration, experiment, instead of monkey see, monkey do. we don't learn anything, but see maybe do monkey see monkey do. If it could be that, make sure you be the king of the monkey, Wukong. If you're going to be a monkey, be Wukong. He is the king of the monkeys. Don't be the little guy, but else be creative and use your imagination and creativity and explore and have fun. If you doubt something, have something in question, don't know, experiment, try it out, and share it with people. Don't bother to go ask. Do it yourself, and you get the answer. It's that simple. It's not hard. When you're curious about something, go do it, find out, see what it is, then share with other people. And next thing you know, everybody thinks you're an expert just because you're just brave enough or dumb enough to try something that people are not willing to try. Or they're too lazy because they have all fear, limiting thought patterns that keeping them from doing it. But you just being your curiosity, you're being an explorer, you're being an adventurer, a brave soul, and you go experiment, try it your first time, you share it. Now everybody thinks you're an expert. Voila. So it's easy to be an expert, right? Just take a little bit of courage, a little bit of curiosity, and a little bit of, I don't know, bravery or just being fearless or dumb. It's very thin line. Yeah, this is the household wire I was sharing about right here. This is the wire they use in Vietnam. This is probably 1 millimeter. And you got 2 wires inside. I guess you can't see well from the camera, but these 2 wires, you strip the wires out and you strip the inside wire. You get 2 of these wires, one red, one black. Then you strip it down further and you get that. So these guys are the same wire, except I threaded this guy up so that it's easier. This is to make a coil. This is when I want to make a copper plate, but I don't have a plate. So I use this guy as a coil. I coil it up. But right now I didn't coil up yet because I do this for demonstration. I use this as a coil, but this guy we can coil up and it works fine. So I think that what we have, we'll wrap it up for now. If I missed something, sorry. We have to include it in a future video, or we have some Q&A at the end of the week for anybody with any questions, share, comment, answer. But let's see what we have. Anybody have any questions? They can feel free to ask right now. Say, is the canophile okay for 12 gauge copper? 12 gauge copper is thicker than 14 gauge. I think you might have to use that whole candle. Try it out. You put it right at the top of the tip and burn it slowly. I think it might work, but you just have to take a much longer. It takes longer to heat. This is 14 gauge. 12 gauge is a bit thicker. I think 12 gauge is 1.8 millimeter, and it takes longer to heat. So with the candle like this here, just put it over. Go slow, 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 slow. Heat it all the way over, then come back and do it again. And it's probably gonna take you like half an hour to do with the candle. So try it out and share with us to see how it works. It might be, I think it's doable, but it just takes a lot longer to heat it up completely, because it takes much more longer to heat a 14 gauge, 12 gauge and a 14 gauge or 16 or 18. So the thicker it is, the longer it takes to heat up. And you might want to roll it around to the other side so that it heats evenly. Okay, it's slow. And in worst case scenario, we make best of what we have. We don't have a flamethrower, not flamethrower, but that works too. Flamethrower, a torch, a flame torch. We can use a candle, match, gas stove, wood fire, whatever we have. Just be creative. We can use, I think people will show before, there's the welding device. You have to do timing perfectly well for the welding device. When you put the 2 things on for welding, will instantly nano-coat. But if you do too bad timing, it's like you toast the wire. I said, thank you, bro. We actually don't have gas stove now. Not many people use gas stove, depends where people live. Some people have, most people use electric, or there's the flat stove. I forgot the name of the new flat stove thing for the electric the thing. But gas stove depends on where you live. Like if you live in Philadelphia, gas stove is common because they use gas for heating and for cooking. Other places they don't have gas, so you use whatever available. But you can go to Home Depot. Home Depot has a Lowe's. They have a similar tank like this for blowtorch, but it's fatter. They have like the blowtorch container like this, but it's like $2, or you get the $40 one. You have different choices. Just get the minimum, the solder pan. They use it for soldering. Use the torch for soldering at Home Depot or Lowe's, and they get the propane, the gas tank along with it, and just use that. It's easy to get, and you're not in lockdown like in Vietnam where the material become tougher. So get the material you have while it's still available before it become lockdown or the case more serious, and it's much harder to get access to simple stuff. Anyone else have any question? We have a quiet crowd, and good. Thank you. Thank you for joining me here today. And for those that want to hear again in Vietnamese, I'll see you tomorrow. And for the rest, thank you and see you again.